All right. Hello, everyone, and welcome. Thank you for choosing to spend your valuable time with us today. Today's webinar will cover the world's first SP800-140Br1 FIPS 140-3 validated certificate number 4718, presented by wolfSSL Senior Software Engineer Kaleb Himes. My name is Emma, and I will be moderating the webinar. All attendees will be in listen-only mode. If you have any questions, please use the Q&A box. After the presentation, Kaleb will answer any questions. As always, all of our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with all the latest from wolfSSL, follow us on Twitter, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to reach out to us via email at facts@wolfssl.com if you have any further questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. This progress is, of course, supported by a strong partner network that we are very proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, a FIPS 140-3 certification and FIPS Ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, Java wrappers and JSSE support, and commercial support for Kernel, and our newest product offering, wolfHSM. These offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We offer full service consulting. Now, I would like to turn it over to Kaleb to discuss world's first SP800-140Br1 FIPS 140-3 validated certificate number 4718.
Hello, everyone, and thank you so much for joining us today. We're here to talk about our FIPS 140-3 module and some of the latest developments and some of the things that you can expect in the near future. My colleague went over this already, so without further ado, what is FIPS 140-3? So for those of you that are not familiar, FIPS is the Federal Information Processing Standard, and there are a series of special publications that back up that standard. And this is mandatory for all federal agencies, or I shouldn't say mandatory, it's highly encouraged for all federal agencies to be using only cryptography that is compliant with the FIPS standard. FIPS 140-2 was the old program, and it was in effect for many years, and it is now going to end of life in September of 26, as you see here on this timeline. So after that point, 140-2 will be completely over and done, and it will no longer be acceptable across any federal agencies. And FIPS 140-3 will be replacing it in its entirety. So what are these standards? What do they do? I kind of hinted at it, but it's basically saying, you know, if you're going to use cryptography in a federal system, you need to be using keys that are of a certain length or strength, bit strength value. You need to be using, for example, with GCM, strong initialization vectors and strong authentication tags. So there's, you know, there are things out there in the world or in the ecosystem of cryptography that are considered weak in practice. And so FIPS says you should not do those things because they're considered weak, and here's are the things you can do that are considered strong. And so any module compliant with those standards, you know, everything that it's doing is offering strong cryptography. I have this leftover bullet. wolfSSL is on the MIP list. We still are. We're still on the MIP list, but we did also receive a 140-3 cert for another submission that we had done last year in 2023. And oh, I guess I should address that a little bit. So the module that's still on the modules in process list, it's actually been in process for about 3 years now. it's currently on hold because the lab working on that submission for us lost their accreditation temporarily, but they're getting it back, and that one will resume its path to certification here in the near future. So what are benefits of 140-3? We've talked about it already, but essentially, you know, by 2026, you have to have it. So it will be the only acceptable solution after September of 26, which is just 2 short years away, and time flies. So 2 years might sound like a long time, but that's often the product development life cycle for some of our customers. So planning now to be prepared in 2 years' time is never a bad idea. 140-3, the changes that it brought along from 140-2 is that it modernized the standard to be more compliant with certifications that were coming out of some of our sister countries, like in Europe. They have the common criteria standards, and they all go by the ISO IEC international standard. And so that's exactly what 140-3 is it's coming up to compliance with the international standard and patching some of the disparities that existed between the 140-2 and common criteria programs. And this way, anything certified to 140-3 should be easily interchangeable with common criteria certified solutions and vice versa. And there are some additional things that common criteria checks that FIPS does not. So, but that said, you know, it'll be much easier to interuse between all the partner countries, the various certifications coming out of those countries. FIPS 140-3 brings stricter requirements and standards, which gives you, the end user, and your customers higher assurances on the cryptography that you're using. Hybrid modules are now a thing, so you can certify like software, part hardware solutions. And you could before as well. It's more standardized now, doing a hybrid module, and it's easier to get through the CMVP with that approach than it has been historically under the 140-2 program. Conditional algorithm self-testing has replaced the old 140-2 power on self-test, which means an algorithm only gets tested the first time it is used, as opposed to forcing you to test every algorithm that exists within the scope of a module as it's powering up. And this is really beneficial, especially to a lot of our embedded customers, and even some of our customers that are running on higher level systems, but where there was a measurable slowdown in their applications starting up because of the power on self-test requirements. Now, for example, if you're doing an application or using an application that's just doing AES encryption operations, you don't have to bother self-testing RSA and ECC and Diffie-Hellman, even though those are all inside of our module boundary. If you never use the algorithm, you never have to run the test for the algorithm. And the way that we design this in our module is you can either let it run automatically the very first time an algorithm is used, it'll trigger automatically if it hasn't been run previously. So the test only has to run once after power on, and then after it's ran the first time, it no longer has to run again, but you have the option to rerun it periodically if you want. And you can also preempt the test. So let's say your application is going to be doing a bunch of really heavy cryptography all at once, but it won't be for a certain amount of time or until a certain event triggers that need. So you can identify, let's say, a low CPU cycle or a time when your application is not doing a whole bunch of work, and you could just manually run the self-test at that point. That way, when it does happen that the heavy crypto fires off for whatever reason, you don't have to bother with those tests at that time or wait for the test to complete before you can do interesting things. So that's basically what all that means. And then finally, processor algorithm acceleration. So this started to be really prevalent, especially with Intel AES&I and the ARM v8 accelerations that have come out in recent years. And we did do a bunch of it under the 140-2 program on our old CERT 3389. But we're seeing a lot of increased demand for this in the 140-3 use cases. And unfortunately, our module was submitted, the initial one was submitted 3 years ago. We then resubmitted it through a pilot program to get the cert we have today. So all the code that's certified is about 3 years old, very stable, highly confident with that code. But the unfortunate thing is 3 years ago was when PAA was just starting to really take off for us, at least for our customers and for what we do. So we didn't have all the PAA pulled into the module boundary when the initial submission happened, and therefore it didn't get carried over when we transitioned from the traditional submission to the pilot submission that resulted in our certificate. But we do have another, well, we have one with the existing cert that we have, 1428. We're going to be doing an update submission to pull all that PAA into the boundary, and that'll result in a new certificate, basically a clone of 4718, but where it'll be revalidated, and so it'll get its own cert number and its own expiration date, separate from the 4718 cert. And we've got a bunch of customers that are doing OEs on that one. And we've also got a bunch of customers that are doing OEs on the base submission as well. So the base submission covers the Intel PAA, but it's the ARM PAA, the ARM v8 PAA is what we're going to get into boundary with the update submission. And there's also some SP single precision math optimizations that we're doing that will be pulled in for both Intel and ARM in the update. So any Intel customers that want to take advantage of like ECC speed ups on Intel chips, we'll get those done as part of the update as well. Just a little background on, the standardization bodies. So there's a couple different terms you'll hear when you're dealing with FIPS. You'll hear NIST, you'll hear the CMVP, and you'll hear the CAVP quite frequently, as well as the term NSTL, which stands for, CSTL, Charlie Sierra Tango Lima, which stands for Cryptographic Standards, Cryptographic Security Testing Laboratories, CSTL. So what is NIST? NIST is the original body that was in charge of coming up with standards and technology requirements for the U.S. federal government. And they've been around for a long, long time. I believe they actually date back to pre-World War I, if I'm not mistaken. And they used to standardize like farm machinery back then. Fast forward 90 years, computer systems, cryptography is coming in. And in the 80s and 90s, the federal government realized they need to standardize cryptography that was in use on computer systems, especially once the internet started to become a thing and computers were talking to each other remotely. And so NIST was commissioned with coming up with a way of standardizing on which cryptographic algorithms were strong and which were weak, and which ones would be approved for use by the federal government and which ones would not. And then NIST partnered with the Canadian Centre for, I can't remember the full name, for compliance or something like that. But yeah, so it was ultimately a partnership between NIST and the Canadian government that resulted in the FIPS standard. Then once the FIPS standard was written and the documents were in place, NIST realized that it was a really big workload to be testing all this stuff. So they stood up a new body called the Cryptographic Module Validation Program, and this body is the CMVP, and they were going to be in charge of testing and issuing certificates to any, and at the time it was only hardware, so any hardware modules that were compliant with the FIPS standard. The CMVP, once they were stood up, realized that the testing portion of this in and of itself was such a heavy task that they needed to stand up their own body just to do the algorithm testing. And so that's where the CAVP comes from, is the Cryptographic Algorithm Validation Program. So the CMVP, their job is to promote the use of validated modules, enforce the security metric used for standardizing and certifying those modules, and they govern the CST laboratories that issue, that do a bunch of the testing with the vendors in advance of the CMVP looking at the work and reviewing the work. So CST labs here is what I was talking about at the beginning when I said CSTL. Oh, and then I should talk about, so the CAVP, all they do is algorithm testing. They issue sets of vectors that you can process with a cryptographic module, and then the results of those tests tell if your module is doing things correctly, but that still doesn't get you certified. Once you've got algorithm certs saying your crypto runs right, you then work with a CST laboratory to do what's called operational testing and code review. So they'll meticulously go through the source code for a module if it's written in software, or if it's a hardware module, they'll look at the hardware design and the hardware design language, and they basically make sure everything is good to go. They test that everything is good to go, and then once they believe it's ready to be certified, they send what's called a test report up to the CMVP. The CMVP reviews the work done between the CST lab and the vendor who makes the module, and they say, yes, you did a good job, here's your FIPS certificate, or you messed something up, or they might just ask a question. And that's what this next slide is showing, is once the vendor works with the CST lab, and then everything gets submitted to the CMVP will then possibly ask questions back to the lab, which the lab then forwards to the vendor. So the vendor doesn't talk directly to the CMVP. We use the lab as a middleman. And once the CMVP is satisfied with everything and you've met or addressed any issues, that's when you receive a FIPS certificate. This is just a high-level design of how we do our releases. So we release an SSL and a TLS stack, and inside that TLS stack is the crypto module itself that gets certified. So once the module is certified, it becomes static and it can never update again or change in any way from the time it was certified. However, we do continue to upgrade and update the SSL and TLS stack, which is, for all intents and purposes, behaving like an application that's just consuming the cryptography. So as we're making updates to our TLS stack, we have to make sure that it not only works with the latest and greatest version of our cryptography that's being developed, but that it also works with all the static versions of the FIPS module that were certified in the past. And so we have a continuous integration test rig that will test the latest and greatest of everything, and then it'll rip out the current cryptography from today, and it'll put in the cryptography from 3 years ago that we submitted to the CMVP, and it'll make sure that the changes made to the latest TLS stack do not negatively impact the way the module runs, and that the old module can still consume everything in a copacetic way with the latest version of the TLS stack. And so we do that for probably 20 different versions of our module at this point, a whole bunch from our now historical Cert 3389. We had a whole bunch of versions that were certified on that one. And then we've also got the 140-3 module now, and we've got other 140-3 submissions that are in process. So we're testing everything with all of those day to day as we're making changes throughout the code base. So what is different about the 140-3 cert from our most recent certificate 3389, which just went historic? This is kind of a delta list between the two. So we've already talked about how the self-tests are now conditional instead of being forced at power on. We added the TLS version 1.3 KDF. So in the past, it wasn't possible to certify the KDFs in their entirety. You could certify the HMAC algorithm used by the KDF. You could certify, if there was any AES involved, you could certify that algorithm. And then you could say, well, we have this KDF and all the algorithms it's consuming are certified algorithms, but now you can actually certify the KDF as a complete component. And so we're absolutely doing that. So we've certified the 1.3, the TLS 1.2, and the SSH KDF with this new certificate. We've also added testing from the very get-go for 3072 and 4096. Those tests did become possible about halfway through the life of our Cert 3389, and we did start testing them back then, but now they're going to be available from day one with our latest module. We also added PSS mode, the padding mode for RSA, and we're certifying that, which we didn't have before. We added the OFB mode of operation for AES and certified that. We dropped triple DES, so if any of you aren't aware, the CMVP invalidated triple DES. It's no longer a FIPS algorithm. On January 1st of 2024, they had announced it a long time ago, so we knew this was coming. So when we started work on the 143 submission, we just decided to go ahead and pull triple DES at that point, which turns out to be a good thing that we did, because we didn't get our cert until July of 24, and triple DES end of life on January 1st of 24. So it worked out nicely. And then finally, our module now supports a degraded mode of operation. So if for some reason one of these conditional algorithm self-tests were to fail, let's say it was for SHA-1 failed its cast, anything that depended on SHA-1 exclusively would also no longer be accessible. SHA-1 would no longer be accessible. The only thing I can think of is HMAC. SHA-1 isn't, as one that would go offline as well. And then you'd be running in a degraded mode of operation, which means one or more algorithms is offline. You can't use it anymore, but all the rest remain available. So SHA-256 would still be there, SHA-384, SHA-512, all the HMACs for those, all the SHA-3 variations, everything else would still be available even though you're in the degraded mode of operation. This next slide is about our upcoming submission. So one of the upcoming submissions we're working on is module version 6. So what I've been talking about this whole time for the 143 cert that we got, that's module version 5.2.1. And so we'll be working on version 6.0.0 next, which will bring, in addition to the 2 TLS KDFs I mentioned and the SSH KDF, we will now also be certifying the SRTP KDF. In addition to that, we're adding AES cipher feedback mode for 1-bit, 8-bit, and 128-bit. And if you're not familiar with these, you know, if and you're curious, just send us an email afterwards and we'll explain a little more. Mostly these are being used in the automotive industry over the CAN, and it helps reduce the amount of errors that could potentially result from a corruption in the lines as data is flowing over the CAN bus. AES XTS mode is coming in boundary. So these are called 256 and 512, but this is really two 128-bit keys and two 256-bit keys. And this is we're seeing a lot of demand for this in the federal space for data at rest, and so that's why we're bringing it into the boundary. AES key wrapping is coming in. Password-based key derivation function 2 is coming into the boundary. The SRTP KDF, obviously. ED-DSA, so we're moving from FIPS 186-4, which is the old standard for public key algorithms, RSA, Diffie-Hellman, ECC, and we're moving to FIPS 186-5, which, in addition to supporting RSA, Diffie-Hellman, and ECC, now also supports ED-DSA. So we're bringing in ED 22519 and ED 448. ED 448 has a dependency on Shake 256, so we're also going to be testing Shake 128 and Shake 256 and certifying those as well. Oh, and this is the bullet just saying all these are going from 186-4 to the newer 186-5. All the ARM v8 assembly optimizations will be in boundary from day one on this submission. And so will all the single precision math optimizations. So that'll affect both Intel and ARM users. So they can start using our SP, it's -- enable -SP optimizations. Okay, so next slide, what defines an OE? I've talked a lot about an operational environment. What is it? This is defined as the combination of the chip on which the cryptography is running, the operating system, which is managing the software as it's being handed to the chip, and the software itself. So our software is the wolfCrypt module. This is how the operating system would get called out. For example, on Windows 10 Enterprise, you'd call out Windows 10 Enterprise. Windows 10 Pro would be considered different. And then this is the level of detail that we have to provide the CMVP for the chips. We don't necessarily have to put on the speed, the gigahertz processor speed, but a lot of our customers like to see it there, so we include it when it's requested. And we used to list these as with AES and I if it was Intel, but from now on, moving forward, this will just say with PAA. And you might hear this term a lot. It comes up when you're talking to our staff or any of your customers that are familiar with FIPS. They might be talking about an OE, and whenever they say OE, this is what they're talking about. The combination of these three elements that gets certified by the CMVP. And then if something changes, like if you move to Windows 11, that would be when the CMVP says, okay, you've got to recertify. And that leads nicely into the next half of this slide, which is oftentimes our customers may be making software as a service or something that can run on many chips, and maybe they sell it to 20 different customers and they have no control over what their customers are using for a chip, and maybe not even the operating system. So we often hear the question, what OE do I certify in this case? And the answer, unfortunately, is we can't give you the answer, but the best advice that we can give is reach out to those customers. How many customers do you have with a FIPS requirement? Figure out who is the procurement officer who makes the decision on what they can and cannot purchase that will satisfy their FIPS requirement. Talk to that procurement officer and just ask them, you know, if we were to certify on an Intel Core i7 7820 and you're running on an Intel Core i7 73200, is that sufficient for your FIPS requirements if we only test the one chip? And they'll either tell you yes or no. And then, you know, wolfSSL offers a service where we add OEs to our certificate on demand. So if there's something you need certified that isn't there today, obviously we can get it certified for you. And it's a lot quicker to add an OE to an existing certificate than it is to go and do FIPS from scratch on your own. We're talking 2 to 4 months versus, you know, 2 to 3 years, which we just went through to get our certificate. So, some of the stuff I'd note here is that desktop, laptop, server. So as long as the operating system doesn't change and the chip doesn't change, it doesn't matter what system we use to test, as long as the chipset OS and the version of our module that gets certified doesn't change between a desktop, a laptop, or a server, it would be considered good to go. It's pretty rare though for a server, which are normally running Xeon chips, to be the same as a desktop, which is usually running a Core chip, Intel Core i7 or Core i9 or Core i5, etc. But desktops and laptops often can share the same OE. And then finally for embedded, so we have some proprietary tooling that makes it easy for our team to achieve, you know, algorithm testing on embedded targets. Even without a file system, it's not a problem as long as we have a full duplex serial communication line to the target. We can get algo testing done on it. I say full duplex serial, but it could, you know, in theory also be Ethernet or something else. As long as we have a way of communicating with the system and we can send data to the system to be processed and then get results back from the system. So it does have to support, you know, full input output, then we can certify it. This slide is, it's a little less relevant today, but in the beginning of our Cert 3389, we used to hear this question a lot. Look, I've done FIPS in the past. Before, all I ever had to list was the operating system and the form factor. What is this about the CPU? Why are we calling out the CPU now? So this is something the CMVP changed quite a while back at this point, where they list all 3 elements now on the FIPS certificate. And so that's why we do it that way. We haven't heard these questions as much lately, but for a while there, we were hearing a bunch of questions about FIPS canisters and FIPS Inside and what are they and how does it work. As far as we can tell, the CMVP does recognize this term FIPS Inside, and it was intended for hardware designs where, let's say you have a little tiny like companion part or companion piece of hardware that fully implements cryptography, and then you have other system components that can talk to that part, and they can say, here's some data, encrypt it with AES for me and give me the result back. And so that's where you would certify that just that minor piece, and then you could put that minor piece on 10 different hardware designs, and all 10 designs could be leveraging the same FIPS certificate. That was the original concept of FIPS Inside. There were some software vendors out there that were trying to say, oh, we certified on this particular operational environment. You're running on a completely different operational environment, but it's fine. Just say that it's FIPS Inside and you're good to go. That was totally a myth, and it was a loophole that some software vendors were trying to take advantage of, and wolfSSL would just put a kibosh on that. You know, we don't do that. If we're going to do FIPS, we're going to do it the real way, the way it was intended. So as far as submission types, if you're already familiar with FIPS and maybe you've been doing it for a while or around it for a while, You may be familiar with the old terms like a one sub, which is what we do when we add an OE to an existing certificate. It's basically a lightweight submission to the CMVP that says, hey, look, we did all the testing for a new operational environment. Will you go ahead and add it to our cert? And that's the 2 to 4 month effort. That's pretty quick. There were also some sub variants of this, like a 1A sub and a 1B sub. There was an old 2 sub, 3 sub, 4 sub, and then a 5 sub was a full submission. So all these names have been reworked. They are no longer called subs for submission types. Now they actually have their own names. So a VUP stands for a vendor update. A VAOE means an OE that's being vendor affirmed, but that OE was not tested and the CMVP hasn't reviewed it in any way, and a CST laboratory has not done any due diligence on it. It's just the vendor claiming that it works. An NSRL is I don't remember what this one stands for. Modifications are made to hardware, software, or firmware components that do not affect any FIPS. I think this only applies to hardware manufacturers, and that might explain why I don't necessarily know it. ALG is an algorithm update, so that means let's say the CMVP were to issue new guidance that said any module that has RSA, they can now test 8192-bit, and it wasn't available when you did your submission, but you want to do it now. So that would be a good chance for an algorithm update. An OE up, that's what we're talking about here. So one sub and an OE up are the same thing. So adding an operational environment update is what that stands for, and that's what we do when we add a new OE to an existing cert. RBND is short for rebrand. It just means we're taking our cert and then rebranding it in a customer's name. It's a marketing exercise. Once a customer has added their OE to our certificate, then if they want to have their own FIPS certificate with their own logo and letterhead for their marketing purposes, they can go ahead and rebrand our cert at that point, and we'll carry whatever OEs they added to our cert onto the rebranded certificate for them. PTSC, again, this is hardware specific. An update, that's what we're going to do to get the ARM v8 optimization into our module boundary. It does result in a new certificate being issued, and this is on par with an old, what used to be called a 3 sub. A CVE is if a CVE is discovered within a FIPS module and it needs to be fixed. This is a rapid submission scenario to allow you to address CVEs in your FIPS module. A TRNS, I think, is a transition algorithm yeah, so that's when the CMVP says if you're using RSA 2048-bit, your module is going to go on the historic list unless you get rid of it. So that would be transition, transitioning away from an existing FIPS algorithm that the CMVP is now saying is no longer FIPS. So triple DES, if we had had triple DES in our submission, we would have had to do one of these to then remove triple DES from our submission. Phys is physical, so that's for level 2 and greater only. Our module is software, so we can only do level 1. Now you can take our level 1 software, put it on a hardware piece, and then take that hardware piece through level 2. So if you wanted to do that, that's always a possibility, but that would be for another day. And then an FS is obviously a full submission. And this slide just kind of goes into detail on what it takes to complete a 1 sub or an OE up. This is like a work log of what our organization does and what our engineers do in the background. And we give you an update each time we complete one of these major milestones. Milestone 1 is just getting the algorithm certs. Milestone 2 is, okay, we've done all the testing with the FIPS lab and they're ready to submit it to the CMVP, and we'll send this update as soon as the lab confirms that they have submitted. And then milestone 3 is the CMVP reviews all the work, approves it, and now the certificate updates with the new OE on that cert. And we are sending out copies of these slides after this on request. So if you want to review this in greater detail, just ask for a copy of the slides and you can read all the bullets in all their glory. So we've done a lot of work in the last couple of years getting our module ready for use as a kernel module. So our FIPS module for use as a kernel module in the Linux space, we've already certified our wolfCrypt FIPS module previously in the Windows kernel space on Windows CE only. We've never done like a 32 or 64-bit UEFI certification yet, but hope to do one soon. But the Linux kernel module development is really stable at this point, and this is a slide just kind of bragging about all that. And it's been fully tested with version 6 and the version 5.2.1 pilot. So it's ready to go if anyone needs that. This is kind of just talking about, some solutions that can benefit from using our FIPS module. So obviously our own TLS stack benefits from it, our own SSH stack, our MQTT, our Wolf bootloader, secure bootloader, our JNI, our JCE, and all of our language wrappers like Python, C#, etc., that consume the cryptographic module. But then third-party solutions, think open source, any open source that consumes cryptography, Nginx, WPA supplicant, Strong Swan, OpenSSH, you name it. If we support one of those third-party apps, they can also consume our cryptography library. And give you that ability to claim, I have FIPS certified crypto running underneath S-Tunnel, for example. And then the biggest benefiter, obviously, is OpenSSL. So OpenSSL saw a lapse in their FIPS certificate a while back, and they had no plans to submit again at the time. There was like over a year that their customers went without a FIPS solution, but thankfully they had what was called an engine, allowing you to plug in a third-party cryptographic engine underneath OpenSSL. And so we were able to fill that gap for a ton of those OpenSSL customers. They came to us, they used our engine interface, plugged in our FIPS certified crypto as an engine to OpenSSL, and that way all their apps using OpenSSL once again had a FIPS certified cryptographic solution to rely on. OpenSSL 3.0 has a very similar concept. They just changed the name. It's now called a provider instead of an engine, and we have solutions for both. And let's see, yeah, I mean, that's kind of the gist of the provider and the engine. Is it's really easy to get set up and running. It's a little more difficult to prove beyond a reasonable doubt that the applications are consuming the FIPS cryptography. So we have done a lot of custom work with our customers, engaged in a lot of consulting to help them set up a way of auditing their systems to ensure the FIPS crypto is really being consumed. Because unfortunately, OpenSSL just doesn't provide a lot of logging about what it's running underneath. So if you need help with any of that, just let our team know. We're more than happy to help. And then finally, this is our what is our 140-3 status? We've done this presentation a couple of times this year, and I'm very pleased to be able to say that as of today, we have a 140-3 certificate instead of the old response we used to give, which was, well, we're hoping to see it soon. So yeah, we have it now. We received our cert on July 11th. Very excited about that, and now we're working on the next one. So we're already working on the SRTP KDF submission, and we're already talking about doing a follow-up submission to that one that'll bring ML-Chem and ML-DSA into the boundary, and we're already preemptively doing testing with demo vectors from the CABP for that today. Some other notes. So we have, I kind of hit on it earlier, but we've got solutions for doing a full duplex serial or Ethernet or however we can talk to an embedded device and running those algorithm tests on those devices that don't support a file system, or other FIPS companies might tell you, oh, we can't certify that because there's no way to load the vector files onto it. That's fine. We've got proprietary in-house tools that we've developed on our own, and we can get it done for you. So just let us know if that's something you're facing. And at this point, I'd like to open it up for questions and just say again, thank you all for attending today and listening to me ramble on. We sure appreciate it.
Thank you, Caleb. Jumping right into the questions, will you include the new NIST PQC standard algorithms?
Hi, this is John Safronic, one of the other senior engineers here. And as Caleb pointed out, that we will be adding we will be adding PCQ algorithms in the near future, probably after the SRTP FIPS build.
Perfect, thank you. Another question here. How can achieving FIPS validation with your certificate help differentiate my company in the market?
Hey everyone, this is Lal. I'm another engineer at wolfSSL. So for that question, number one, it just expands your pool of potential contracts, government requirements, industry requirements. You'll be able to fulfill those needs if you have FIPS validation, and it also just brings a lot of credibility to your solution. There's a lot of testing that goes into this, so it really makes a difference.
What does the transition from FIPS 140-2 to FIPS 140-3 look like?
So that transition, so there's two aspects. There's the technical aspect, and then there's the high-level broad aspect. The high-level aspect, if you've already been a 140-2 customer with wolfSSL, not much is going to change. It should be take in the new bundle that we're providing, and then if you have to refactor slight things because of some of the changes, like for example, DES3 being removed, then you'll have to remove DES3 from your old code base, and then things of that nature might come up, but should be a smooth one. As far as the technical aspect, there's a lot more flexibility with 140-3. We have the degraded mode, as Caleb mentioned, so it's gonna require a lot less reboots, a lot less figuring out what to mix and match to get things working. So shouldn't be too bad at all.
Perfect. And then one last question here. What is the benefit of having my operating environment listed as a tested configuration under your cert?
So your choices are to get a full cert on your own, or we can white label our cert for you. So having to do your own cert for your operating environment will take over a year. You could then add, or you could add your operating environment to our cert, which is just a change, and then we can get a cert with your name on it rather than our name. And it's a matter of time. It's a month rather than a year. So that's the big advantage to adding your OE to our cert.
Perfect. Well, thank you, Caleb, Lalam, and John for hosting an informative webinar. Thanks to everyone for joining. I will email a copy of the webinar recording and PDF slides. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions at all, don't hesitate to shoot us an email at facts@wolfSSL.com, and we're here to help. Thanks again, and we're looking forward to seeing you next week on September 5th for Mastering libcurl command line training. Thank you all.